This is how it works. Zoro is a quick name for you to remember what you should do. And like how Zoro does, he does like a little fast sword action. And what we do with when we find common denominators for fractions. So, as we so, we do our first slash. Sound effects by Mr. Link. 3 times 7. Okay, this is our first slash. We do that every time. And right away, we go down the bottom. 3 times 7. 3 times 7. Remember, Zoro always does 3 swipes. That's our first swipe. Our second swipe. 7 times 2. 7 times 2. And our last swipe here. 3 times 6. 3 times 6. If you notice, you can see from up here, 3 times 7, 3 times 7, 3 times 7. So we both know that these are going to have the same denominators because they have the same factors multiplying each other. Afterwards, we have 7 times 2, 7 times 2, 3 times 6, 3 times 6. So let's see what that gets us. 7 times 2 is 14. And we know that this is over 21. This is over 21 as well. And we know that 3 times 6 is 18. Okay? So now, at this moment, we have common denominators. 14 24s plus 18 21s plus 18 21s. So we can have the common language of speaking. So now we can add these across. The common denominator stays the same. We add 14 plus 18. 4 plus 8 is 12 ones. 110. 1 plus 1 plus 1 is 3. So our answer here is 32 over 21, which is a improper fraction. Yes, because the numerator is greater than the denominator. Now Ms. Patel is going to go over and tell you how to put this in decimal form using our code words.
So Mr. Link just got us to our sum, 32 21st. Now what we need to do is we need to take this improper fraction and turn it into a decimal that makes a little bit more sense. So this right here is our division sign. This is 32 divided by 21. So we have it written one way as a division problem here, another way here, and the final way we need to do it is some way where we can actually find out what the answer is. So we're going to take 32, top goes in, bottom goes out. That's what division is all about. Now we need to divide. Before we divide, we're going to have a decimal answer. So I'm going to go ahead and add my decimal point and add my zeros. My values stayed exactly the same. All I did was add the details that were missing before. So I cannot divide 3 by 21, so I'm going to do 32 divided by 21. 32 divided by 21, 21 goes in one time. Divide, multiply. 1 times 21 equals 21. Subtract. 2 minus 1 is 1. 3 minus 2 is 1. Bring down. Now, I don't know about you, but counting by 21s is a little bit difficult for me. So I'm going to go ahead and skip count across the top to make sure that I don't make any mistakes. 21 plus 21 equals 42. Plus 21 is 53. Plus 21 equals 74. Plus 21 equals 95. I made a mistake. I made a mistake. I don't know if anybody else caught this. I said 4 plus 2 is 5, and 4 plus 2 is actually 6. And because I messed up here, that means that I messed up in the next one too. 63 plus 21 is not 74. It's actually 84. And 84 plus 21 is actually 105. Plus another 21 equals 126. Now that gets me to where I am right here, 110, which fits in between these two numbers. So it's 1, 2, 3, 4, 5 full groups of 21. 5 times 21, like I skip counted before, is 105. If I subtract that, I get 5, bring down my 0. 50 divided by 21, that fits in right here. It's 2 groups. 2 times 21 is 42. Subtract that, get 8. Bring down my 0. I have 80, which fits in right here between these two. It's 1, 2, 3 groups. 3 times 21 is 63. I subtracted that, and I got 7. So it looks like I could keep on going, but I'm going to stop here and round it off to the nearest thousandth. So 32 21st is equivalent to 1 and 523 thousandths.
I love fractions, especially when they're unlike. So we have 2/3 plus 2/4. As you can hear, both times I said a different denominator. So here we have unlike denominators. What I want you to do right now is pause the video for a second, use Zoro and find the like denominators of these two fractions. For pausing the video and taking your time to actually do it, being responsible and making sure that you at least try to do it first. So, what did you get for your like denominators? Say the answer for me on 3. 1, 2, 3. Yes, 12. 12. So, we did our first Zoro. That's our first one, our first swipe. So we have 3 times 4 plus 3 times 4. Now, I want you to pause the video once again, and I want you to find the numerator for this fraction. Find the numerator for this fraction now. Thank you for pausing the video and finding it. So, what was the numerator that you got? 8. Yes, it is 8. Going from here, our second slash, 4 times 2, 4 times 2. Now, for this last one, pause it one more time and see what you got for the numerator for this fraction. Okay? Yes, the last one is 6. 3 times 2. 3 times 2. Okay? Now, we're going to multiply all these out to see exactly what we have to add together. So here we have 6. 3 times 2 is 6. 4 times 2 is 8. And both will be over 12. Okay? Now, see and add these together and tell me, is this an improper fraction or not? Will this be an improper fraction or will it be a regular fraction? Okay, now after you add it, you should see that this is an improper fraction. 8 plus 6 is 14 over 12. Why is this an improper fraction? Metacognition with your little brother, sister, or cousin and tell them why it's an improper fraction. They might not know why. So it's your duty to tell them. Yes, you tell them this. The numerator is greater than the denominator, which makes this an improper fraction. Now we're going to skip to Ms. Patel to make sure that she can teach you how to convert this into decimal form.
Okay, so this is an improper fraction. Our goal now is to convert this to an equivalent decimal to get an answer that makes a little bit more sense. So take a second just to set up a number sentence that can help you find out what decimal 14/12 is equivalent to. So our number sentence is going to be a division sentence. We have 14 divided by 12. So to put this into a way we can actually solve it, top goes in, bottom goes out. Pause the video here to see which decimal you get and see if it matches what I get in the end.